Hello and welcome everybody to today's lecture about protection in electrical power systems. And today's lecture is about coincidence probability of rare and short situations, which is quite special. So let's see, a hazard is normally defined as a potential source of harm, and that can turn into a risk. That means the likelihood of real harm if there are two conditions fulfilled. One is that the source of harm exists and, this is a logical, and the contact with a vulnerable person coincides. Now let's see about the model, how to calculate this. So let's see, we have a hazard situation on top. The event A is the hazard. That may occur, but there is no contact, so this is safe. Nothing will happen. The same occurs if it is vice versa. That means we have no hazard, but a person is present, so nothing will happen again, and the situation is safe. But now we can have the situation that while the person is present, you see this red rectangular, then the event A, the hazard, sets in, and that means something will happen. The same occurs if we have a hazard situation existing and a person coming into it. So then this is the person enters this hazard situation. We call this the case B. That means the contact phase starts during the hazard phase. So now a little bit about probability calculations. So we start again with this case where the hazard sets in. It can be one event, it can be later. So this is the course of a year, and in this year we think we have, for example, 10 hazard situations. Now, how about the event B? That means the contact situation. For example, if a person is in contact with a dangerous electrical equipment for 6 months, half a year, then 50% of the hazard situations will turn into dangerous situation. The same will happen, you see here, half of the events is with no consequences, half of the events is dangerous. This is indicated by the red figures of 1. The same situation may occur if we have this contact situation distributed over 1 year with an average contact duration of 2 months, and this happens 3 times, so it is 6-month contact situation again. Is the same output as before. Namely, we have 5 dangerous incidents. So to calculate this is we take the frequency of the hazards, Fa. This will be diminished by the factor of the presence of this person, and this can be, if we split it up, into the sum of the single presences, which in turn, if it is more or less regular, can be presented by the frequency times the average time, as we have seen before. And then this comes to this famous formula. In our concrete case, we see that this is 10 is the number of presences times 3 events, average per year, with a duration of 2 months per event. Then we arrive at this figure 5. So this was to prove the formula. So in short, the hazard starts during the contact phase is given by the frequency FAB, we call it. Of course, we can consider case 2. This is when the contact phase starts during the hazard, and this is FBA, and you only have to interchange the letters A and B, but principally it's the same. And now we can have both situations. The probability and frequencies that something happens can be either this or this, and the probability of 2 events, as is well known, is given by the sum of these single events minus the product, but taking into account that these events have a low probability by themselves, the product can be neglected, and we enter with simply the sum of these. And this is the miraculous formula of the frequency that a dangerous situation may occur during a hazard phase. Now we have an application, the so-called Australian jogger, which is well documented in the regulation EG-0, which is an Australian de facto standard. So we see here an overhead line, which, in case there is a flashover, turns into hazard. This is the hazard. Then we see a jogger. The jogger comes by and stretches himself by putting the legs and the hands to the fence, and this is the contact phase. And now let's see about the frequency. Is this dangerous, or what is the probability? Principally, it is dangerous. But as everywhere in real life, there is a residual risk, and we want to look at this. So now in figures, the event A, the hazard, occurs every 1,000 years. This is proven by statistics, for example, and it lasts for 1 second. After this 1 second, protection trips out. The jogger comes by 365 days per year and is in touch with this fence for 4 seconds. Now we go into this formula, and when we do this, we arrive at the figure of 0.058 times 10 to the minus 6, which is well below the sometimes called magical threshold of 10 to the minus 6, which is regarded as more or less acceptable residual risk. So this was today's lecture about coincidence probability of rare and short situations. I thank you very much.